Okay, with 11.6, we were talking about volumes of pyramids. Remember, pyramids are shapes that come up to a point. So down here, we have square pyramid, just a pyramid, because it has a square base. And I want you to take a look at this image here. What this says is we have a pyramid on the left that has the exact same base as this prism over here. Okay, now we found the volume of prism in 11.5. It was the area of the base times the height. Today we're going to be talking about, well, what's our formula for volume of a pyramid? And it is a little different. In class, I'm going to show a little activity. So if you weren't in class, I'm sorry you didn't get to see it, but it's essentially this. When a pyramid is filled with sand and poured into the prism, it takes three pyramids to fill up one prism. Okay, so if the pyramid and this prism have the exact same base, which they do have the exact same base, they say that, and the exact same height, which they do, then it'll take three pyramids to fill that one prism. I'm going to scroll down a little bit here to show you what our formula is. It has something to do with that. It's 1/3 times base times height, where B is the area of the base. Again. Okay, so we have to find the area of the base, multiply that by 1/3 and the height. Okay, so that's where that 1/3 comes into play. Let's go back up top here. We're trying to find the volume of the hexagonal pyramid. This is a tougher problem that we're starting out with. I don't know why we're starting out with it, but we can. First thing we have to do is find the area of this hexagon. Remember, area of a polygon is 1/2 times the apothem times the perimeter. The perimeter of this hexagon is 6, so we know P is 6. We need to find the apothem. Okay, we need to find the central angle. 360 divided by 6 is 60, which means half of it is 30. And we need to find A. We know that this is 1, so we're going to take the tangent of 30, set that equal to 1 over A. Multiply both sides by A. So A times the tan of 30 is equal to 1. Divide both sides by the tangent of 30. So 1 divided by the tangent of 30 is 1.7. So in our formula, just for the area of that hexagon, we have 1.7 and then 1/2. And we have to multiply those three things together. Multiply this by 0.5. And what did I say the perimeter was? Perimeter is not 6. Sorry, the perimeter is 12. Holy cow, you're probably getting so confused. Perimeter is 12. I'm sorry. Multiply this by 12, and we get 10.4. So the area of my perimeter, or my polygon on the bottom, is 10.4. We need to find the area of this entire pyramid, find the volume, which is 1/3 base times height. Base is 10.4. So we have 1/3 times 10.4 times our height, 3. Okay. If I type that into a calculator, I know that 1/3 and 3 cancel out. So I know my volume is just 10.4 inches cubed. We know how to find the volume of a pyramid. Composite solid. Let's see here. Sorry. we're going to skip composite solid. We know what a pyramid is. We've discussed it in the past. We're going to go down here to number 1. Remember, volume of a pyramid is equal to 1/3 times the base times the height. So you're going to find the area of the base, and this is a triangular base because 1/2 base times height. So base is 6. 6 times the height 4 divided by 2. That's 24 over 2, which is 12. So my volume is equal to 1/3 times 12 times my height 9. I can simplify 1/3 times 12. That's 4 times 9, which is 36. 36 centimeters cubed. Rectangles. It's a rectangular base or a square base because it's 6 and 6. Remember, you just multiply 6 times 6, which is 36. So volume of a pyramid is 1/3 times my base times my height, which is 8. Okay, and if we calculate this, 1/3 of 36, I know that's 12. So it's just 12 times 8. 12 times 8, 96. Remember to label inches cubed. So it's just the area of the base times the height, and then divided by 3 or multiplied by 1/3, however you want to look at that. Okay, I'm going to skip these 2. It's the exact same as the top. Number 5, they give us the area of the base. That's nice. It's 27. So the volume is 1/3 times 27 times 5. Well, I can, again, I know what 1/3 of 27 is. That's 9. Times 5 is equal to, sorry, not 35, 45 centimeters cubed. This one, it's a rectangle, the base. So the area of the base is 4 times 1, which is equal to 4. So the volume is 1/3 area of the base times the height, which is 6. Again, if I solve this, I know that 1/3 of 6 is 2. So we're going to have 2 times 4, not 2, 2 times 4, which is equal to 8 feet cubed. Down here it says find the indicated measure. A pyramid with a square base has a volume of 128 cubic inches. It gives us the volume. And a height of 6 inches. Find the side length of the square base. Okay, this is a little different. B is going to be the area. We're going to first start by finding the area of that base. 128 is equal to, I'm going to combine the 1/3 and the 6 to make 2B. I'm going to divide both sides by 2 when I get 64 is equal to my base. Now, it's asking for the side length of a square base. If I made a square, okay, and it was 64, inches squared, that's the area. What is each side? Well, to find that, I have to take the square root of 64, which is 8. I know these are 8 and 8. So it's going to be 8 inches. Next, a pyramid with a rectangular base has a volume of 6 cubic feet. So they give us the volume. The length of the rectangular base is 3 feet, and the width of the base is 1.5. So I'm going to actually draw this. Okay, the length is 3, the width is 1.5. Let's find the area of that. 3 times 1.5. For whatever reason, I can't do that in my head. I'm just going to type it in my calculator quick. 4.5. So I know this is 4.5 feet squared. So the area of the base is 4.5. The height is what we're trying to find. So this one is a little different. I can't do this one as easily. I'm going to take 1/3 of 4.5. So I'm going to take 4.5 divided by 3. It's the same thing. That's 1.5. So 6 is equal to 1.5h. Let's divide both sides by 1.5. And we get 4. So the height is equal to 4 feet. Number 10. It says the pyramids are similar, which means they have similar side lengths. They have a scale factor. They have a scale factor of 15 to 10, 15 over 10. That's their scale factor. Which is really, if we simplify this, divide both by 5, it's 3 over 2. Okay, or 2/3. So if I multiply 15 by 2/3, I will get 10. The other way we can do this is set up a ratio. 15 over 10 is equal to the volume of the top over the volume of the bottom. Okay, so cross multiply 15V is equal to 1250. Divide both sides by 15. 1250 divided by 15 is 83.3 inches cubed. Okay, again, similar, we can set up a scale factor ratio of any sort. All right, made a mistake. I made a mistake here. Sorry, my apologies. This comes back to chapter 8, way back when we were talking about scale factors or ratios of area. We had to square the side lengths. I stressed that. I made sure you remembered that. You square the side lengths. Well, in this case, when we're talking volume, we cube the square lengths, or the side lengths. We square or cube the side lengths. Oh, we cube the side lengths. So what we have to do is cube 15 and 10. So 15 cubed is 3,375. So we'll rewrite this. 10 cubed is 1,000. That's equal to 125 over V. Okay, all we do is cube the side lengths, not anything else, not the volumes, the side lengths. Cross multiply. All right, 1,000 times 125 is equal to 125,000. That's equal to 3375V. Divide both sides by 3375. And we get 37. So V is equal to 37. Inches cubed. There we go. My bad. My apologies from the